All right. Not that wall. Anyways, so we're recording again. Right now what I want to talk about is something called the communicability of loops. What? Yes, I am. No, I was recording.
Oh, it said stop on here.
Oh yeah, no, because I had my cursor over the stop button.
It says record on. You're still yellow?
Oh no. No, you should probably reload.
So far behind that.
Anyways, so Justin's about 45 seconds behind at this point.
I'm a little slow. Stop picking on me.
Anyways, like I said, communicability of loops. And I keep changing how I say that word. My tongue is not cooperating at this point. For and while loops are two sides of the same coin. And they can actually be written in such a way that one can complete the task of the other in the same way as the other one. Does that make sense? That didn't really come out though as concisely as I want it to be. So let's look at it this way. This is our for loop from the beginning. Remember that this counts up 0 through 9. Okay? So let's break out the for loop into its pieces and turn it into a while loop. Okay? So I'm going to use a variable called j this time. And I'm going to set it equal to 0. Okay? And then I'm going to say while I is less than 10. Oops, not I. Apologies. While j is less than 10, system.out.println j plus plus. Does this highlighted piece of code complete the same task?
Yes. It adds 1 to j every time. It comes up j.
Okay. Let's see.
I have a feeling that you're going to put a different number.
You were right. That is the way it works. Oh, okay. He's still catching up again. So this is the idea behind the communicability of loops. Communicability of loops. It's a very long word with a lot of syllables, and I can't really, when my mouth starts to dry out, it gets kind of difficult. Anyways, I'm not even quite sure that it's a word. Communicability, or somehow, I should probably have Google say it instead of me trying to say it every single time. But anyways, maybe, I don't know. Now, my question to you two, Hunter and Justin, is which do you think is easier to write? The for loop or the while loop?
The for?
In this situation, I should say.
I'm going to have to go with the while. I think the for is...
In this situation, it's actually leaning more towards the for loop. It's not wrong to write it with the while loop, but in terms of the task trying to be completed, it's much more concise and easier to look at the for loop. And you'll find that in a multitude of different situations, you'll have to sort of make the best educated guess as to what is going to turn out to be the best thing to use to complete your task. For this one specifically, I would say that what I would want to see if you were writing this piece of code yourself, I would want to see you use a for loop. Now, would it necessarily be wrong if you used a while? No. You would probably still get a healthy number of points for completing the task that I asked you to do, but you would probably lose some points because the conciseness of your program wasn't all there. So I'd like you guys to keep that in mind as you're writing your programs and trying to decide what loops to use in order to complete a particular task. My mouth is starting to dry out for some reason. I had some water within the kitchen, didn't I? Communicability. Okay. Anyways, thank you, Pete, for making it a little bit easier on my tongue. I don't know what I was trying to say there, but communicability. Blah. For anybody new to the team that may be watching this, I'm so sorry. I am so weird. It's just, you'll get used to it, I promise. So the next thing that I'd like to talk about is something called nesting, and we've seen a little bit of nesting with for loops, and this actually goes back to the idea of the Russian nesting doll sort of deal, the grimoire, as it were. Nesting is the idea that you can put multiple control structures inside of each other. So an if statement inside an if statement, a while loop inside a while loop, a for loop inside a for loop, an if statement inside of a for loop. What?
I did that on the last one.
You did, yes.
Because I tried doing like the you got the wrong password thing, and so I did that, and even when you did get the right password, if you just did system.out the wrong password, like in the curly bracket things, it'd say wrong password with correct password too. So I had to do an if statement saying if it wasn't right, then do it.
Okay, we'll have a look at. I'll have a look at how you did it, but anyways, let's keep going here. The idea behind this is you can have as many layers as you want. You can go as many control structures deep as you need to. In fact, Justin probably saw, albeit kind of delayed earlier while we were still waiting for you two to come by. Justin saw some of the code that I'd like to release in the next week or so for controlling a certain type of LED directly from the RoboRio. That in that situation actually has multiple situations where there are multiple nested levels of code and control structures that all work to complete the greater task at hand. I may not show any of that today just because,
Crazy complicated.
yeah, it's a lot bigger than anything that you guys have seen so far. It spans 12 files, I think. So we won't go there. No, it's for strips of LEDs.
Yeah, 12 files for one LED. You got a strip of 64. Oh boy, you're gonna be busy.
But this is just going to be a very general example of what it might look like in order for you to be able to create a nested structure inside of a for loop, or a set of for loops, I should say. So the first thing that I'm going to do is I'm going to create another for loop inside of here, and I'm going to say int j equals I.
Oh, mine works.
J is less than or equal to I. No, I'm sorry. I messed that up. Int j equals 1. Okay? I'm getting there. I promise. I'll figure this out. If I would read my notes, it would help. J is less than or equal to I. J++. And then what I'm going to do is I'm going to say system.out.print. Print. J. System.out.print space. And then we're going to close this up, and we're going to say system.out.println
Wait, what?
empty.
What does print do?
We talked about print in what, the second class?
Probably. Just print alone?
It it prints on the line and doesn't move the cursor down.
It's like on the calculator assignment where you can press enter, and then that's where you come up with the next line.
So like, Justin,
Yeah.
you know how with print line it starts on a new line each time? That's because at the end of what you put in the print line parentheses, Java appends a special character that tells the console, put the cursor on the next line. The only thing that print does is it doesn't put that extra character there.
Oh.
It stays on the same line.
Oh,
Okay?
okay. So we're gonna have one line.
Well, now let's talk about this a little bit.
We make one space.
Let's talk about this before we start making assumptions. So we have a nested for loop, okay? So first step is initialize I to 1, okay? The next step is check I less than or equal to 5. Which, let's put 1 here. So check 1 less than or equal to 5, which is equal to true. Okay? So now we're going to move on to this body of code. Okay? This is our next step. So the first thing we need to do is we need to initialize j equal to 1. Well, to 1, let's say. Let's keep it consistent. And then we're going to check to make sure that j is less than or equal to I. So in this current instance, I is 1, right? So it's 1 less than or equal to 1.
Yes.
Oh.
One is less than or equal. Yeah.
So true. And then we're going to do the block of code inside that for loop. In this case, we print j, we print a space, and then we say j equals j plus 1, which would be equal to 2. Okay? So then we check our condition again. 2 less than or equal to 1. Right. It's false.
Okay. So I see why you use the space. The space is so that it's 1, empty 2, empty 3, empty.
Well, you're still not getting me here.
No?
Actually, this should say print. I'm sorry. This should actually say print. That was a mistake on my part.
Oh, okay. So you go to 1, space, 2, space.
Right. But what is this structure going to look like?
It's going to be a line.
Is it going to be all one line? Because what finishes out the outer loop? A space or a new line? Okay.
Oh, and it says system out print line. At the bottom.
Yes, that's what... Does one ear turn on and one ear turn off?
But
How does this work?
I don't get why you have the space and print up inside it.
So, Justin, think about it like this. We initialize I to 1.
Yeah.
We check our first condition of the outer loop.
Yeah.
I is less than or equal to 5, which is true.
Yeah.
We initialize j.
Yes.
Okay? We check to make sure that j is less than or equal to I.
Yeah.
Okay? So this is going to print 1 and a space. Okay? We then add 1 to j, which makes it 2.
Yes.
2 is not less than or equal to 1.
Yes.
Okay? So then we come out of this loop, we print a new line. Okay?
Oh, okay.
We then come back up to our outer loop and add 1 to I. So now I is 2. Okay?
Yeah.
Now that I is 2, we reinitialize j to 1. We then print 1 and space, because I is less than or 1 is less than or equal to I. because I is now 2. So we print a 1, and then we go J++, which makes J 2. Is 2 still less than or equal to 2? So then we print 2 and then another space in the same line. Perhaps it would be better if I just... Are you getting me, or are you...
Catching on a little.
Okay, let me show you what it looks like when it's all done. Because this is not getting me anywhere.
Oh, hang on. Keep it on that screen.
Oh, okay. That makes sense.
Oh. Oh.
It's just like with the Wilder, where you can either go up or go back.
In this instance, what's happening is the outer loop defines how far out each line can go. Does that make sense? Because remember that our condition for our inner loop is I, is everything needs to be less than I, okay? But I keeps changing each time the outer loop runs through. The outer loop is defining how much work the inner loop can do. Okay? Does that make sense?
Yes.
This is a bit more of a rough and tumble version of explaining how nesting works. Normally when you talk about nesting, you talk about it in the context of two-dimensional arrays, but we're not there yet. So this is my way of sort of outlining how this works here. One other thing that I would like to go over is something called break and continue. You know, it's warm in here. One thing that I'd like to go over really quick is break and continue. Break and continue is used with looping structures in order to make it so that you can either skip steps or leave a loop altogether. Okay? You follow me so far? So let's look at continue first. So I'm going to say in this loop, if j double equals 3, continue. And that's all I'm going to put in there. What do you think is going to happen?
It's probably only going to have until it gets up to 3.
No, it's not.
Is it going to stop at 3, or is it going to skip 3?
No, it's not going to go past that until it gets to 3.
Let's have a look.
Oh boy. Hang on.
That didn't run the way I'd expected it to.
I don't know how to play it.
It doesn't even look like it ran. Where did I run? Did I not compile? Maybe? Let me close this. Try this again. I have so much... Oh, it's because I put it in the wrong friggin' spot. I put it in the wrong spot, guys. Alright. I'm having a rough day. Might be getting a little dehydrated. It's okay. Alright, let me clean up a little bit. So, I should have had it at the top.
So now all it's going to do is it's not going to do anything until it gets to 3.
Bear with me here.
Oh my goodness.
Because now it's going to work the way I expected it to.
Well, it's hit 3.
Hang on. Oh, it's skipped 3. Why did you do that?
Because continue means run my modifier equation and check my condition again. Skip all the rest of the code, no matter what, and run the modifier equation and check the condition again.
So basically, when it goes 1, 2, but when Lisa 3 doesn't print it, it checks the equation over again and then continues on.
Right.
Okay.
So it would do 1, add 1, 2, add 1, 3, wait, skip, add 1, 4, add 1, 5, and then,
Wait.
right. So
Wait.
this is the idea behind how this would work for you. This is what continue does. Continue is normally used in situations where there may be a certain condition of a loop that might normally cause it to stop or maybe cause a problem with what you're doing, and that allows you to skip over that step and continue on, even though there may be other numbers that come after or more options for the condition that may come after that mean that can still be enacted upon, but you have to get through this part of it first before you can do anything with it.
Quick question. Could you actually use continue twice? Like, could you have it skip over one number and then pick another number and have it skip over that one as well?
So let's look at that. Let's say we wanted to say else if j double equals 5. Continue. And we compile. Now we skip over 5 as well.
Okay.
So it's safe to use continue in multiple different instances inside of a looping structure, but know that depending on where continue is, certain pieces of your code may not run for that particular step, which is why when I ran it originally with it at the end, it caused me a bunch of problems because I screwed up. Okay? So just keep that in mind, that placement is key. As with variables, if you try to use a variable before you've declared it by saying like int I equals 0, you'll get an error because it doesn't exist yet. Just like with continue, if you put continue somewhere and a bunch of code that you don't want to run has already run, or it's running before a piece of code that you do want to run, you may not actually hit what you want to hit. So now let's talk about break. Break is a little bit more violent. Break just says if you hit this condition, stop immediately. Break out of the loop. You're done. No more steps. End.
So just stop the program right there.
Not stop the program, the loop.
So basically, if this was using a robot, you could be saying, keep walking forward, but if you hit something, just stop.
Yeah, essentially. That's the idea. So in this case, I've changed if j double equals 3 break. And let's see what happens here.
Now, would you do? Now, is this the same thing as continue where you put it at the top?
Yes.
It says that continue. You type it.
Right. So you can see that we stop at 2. We never make it any further than 2 because each time the inner loop hits 3, it stops. It doesn't keep going.
Oh, so it doesn't like just stop the whole entire loop.
No, only the inner loop stops.
I thought it would like go 1, 2, then just stop.
No, the outer loop keeps running.
Oh, okay.
The outer loop runs. The inner loop every time it hits 3 just stops. Make sense?
Okay, I'm somewhat confused because
So-
you had the other page after you had 1, 2, 4, but you had it twice. So it would stop at 5. It would break at 5 again. Or
Break at 5? Or break it... We're breaking at 3, remember?
can you compile this and hang up the other page real quick?
You mean like this?
I guess it's
Yeah, mine is all good now.
mine's frozen where you have it. I'll hide it.
Oh,
Mine's all good.
Well, that's interesting.
Okay, never mind. That's fine. See,
Yeah, go ahead and reload, Hunter, and you may.
Wait, oh, there we go. There we go.
Okay.
Oh, there we go. Because all I have is like 1, 2, 1, 2, 1, 2, 4, 1.
And that was with continue.
Okay.
This is what break looks like.
I thought it was kind of funny because like, there we go.
Boy, I didn't have this much problem last week with Hunter Loader. I'm not quite sure what's going on this week. It must be. I wonder. My dad's still casting. I don't see any cast activity on the network, so there's a Chromecast in the camper. Unless he's out mowing, but I think we would hear him.
I can mess up with the Wi-Fi.
What?
I can mess up with the Wi-Fi.
No, the Chromecast can though. The Chromecast uses up quite a bit of bandwidth, but it shouldn't be maxing out the router unless something else is going on.
We all checked it.
Might be getting DDoSed again. But anyways,
Sorry for the
no, that's fine. Not a big deal. I was a little confused myself as to what you were trying to get at. No. So this is the general idea of nesting and continuing break. I just wanted to show this to you guys to make sure that you had this basis, because it while you won't use continuing break very much, you will do some nesting and robot programming. It will come up, and I wanted to make sure that you saw it.
43 megs download. You are crazy.
What?
You have 23 megabits downloading. Hang on.
So I don't know what Justin is talking about. He's not making any sense.
The internet speed is fast.
No, he's going through.
Justin, that's 23 megabits per second, not megabytes. That's a very different number. And it's not that fast. Anyways, the next thing we'll talk about real quick is the assignment, and then we'll have some discussions off recording about what we're gonna do about Justin's computer and Hunter's computer in the coming days here.